Time's up there, and I got 8 of you to try this. So I was looking through your answers, and the ones I found that were correct, I'm going to present those to the class. And so this person did a nice job of showing that they were dividing out the GCF of x minus 2. That's the common factor that we have here. And so the factored form is x minus 2 times 3x plus 5. This person also did a nice job showing that, and they crossed out those common factors in the numerator and the denominator. And then they highlighted what was left, the 3x and the 5. We have addition here, so that became 3x plus 5. Another correct one, that one's good. You know, these are sometimes you do them in your head, but you want to get in the habit of putting your work down. I know there's like factoring calculators that you can use online. So I just want to make sure that you guys understand the process without using a factoring calculator. So if you show me some sort of work, then I know that you're actually doing it yourself. And like by showing work, I mean like something like this is perfect. Okay. So any of you guys have questions just on the warm-up, like how we got that answer or how you do that? This is kind of like what we learned about yesterday. All right. So before we get started here too much, we just jumped right to step 3. And that's what that warm-up question was. We were factoring out the common binomial. And so we're going to be doing that still today, but now we're going to look at, you know, what might it look like before we get to that point and when you can use it. So if you have a 4-term polynomial, so you have 4 things being added together, but if you look at them and you can't find a GCF, a greatest common factor amongst any of those terms, then this is something we would try. We would try factoring by grouping. And so the first step to that is to group, which means to put parentheses around the first 2 terms and then also around the last 2 terms. So you're basically taking a 4-term polynomial and splitting it in half, and you're just going to look at each half separately. And so the second step is to factor out a GCF from each separate binomial. So once you split it in half, you look at each problem as 2 separate problems. And sometimes you can find things that will factor out, and then it'll end up giving you something like we've been looking at so far, where we can factor out a common binomial. So this is what we're going to do. And this slide right here, so the example on the left is already all worked out. So let me just explain what's going on here. Our polynomial is x cubed minus 2x squared plus 5x minus 10. And so if I look at each of the 4 terms, there's no common number or coefficient I could divide out. There's no common variable I could divide out. So there's no GCF except for 1, which doesn't really help us change it. So I'm going to try this grouping method, this factoring by grouping method. So they put blue parentheses around the first 2 terms, and they put blue parentheses around the second 2 terms. Okay, and then they just look at each of these as separate problems now. Notice the plus sign is not in the parentheses. So over here, it does have a common factor between just these 2 terms of x to the 2nd power. So if I divide x squared out, I'm left with x minus 2. And then looking at the second binomial, 5x minus 10, well, 5x and 10 have a common factor of 5, so we divide 5 out, which leaves us with x minus 2. Now, by doing this, it's given us something that we saw yesterday and that we've seen in the warm-up today. It's a common binomial. It's a common factor of x minus 2. X minus 2. So at this point now, we can divide out x minus 2 from both of these terms. And then x minus 2, you write first in parentheses. And then what's left over is in blue. X squared plus 5. And now it's completely factored, which means when it's completely factored, it's just a product of things being multiplied together. And there's no common factors left to divide out. All right, so if you look at x minus 2, there's nothing in common here. X squared plus 5, there's nothing I could divide out here. So we're going to try this method, starting with this polynomial over here. So x cubed plus 7x squared plus 5x plus 35. To use these steps, you want to check to see, is there a GCF in these 4 terms? X cubed, 7x squared, and 5x. So the first 3 terms all have an x, but the last term is just a constant. The last 2 terms are both divisible by 5, but the first 2 terms are not. So we don't have a GCF. So this is a good type of polynomial to try this method on. My bad. Wrong way. So first step is to group the first 2 terms together and the last 2 terms together. So we are going to just draw in some parentheses, 2 pairs of parentheses around the first 2 terms and around the second 2 terms. My Pear Deck's going slow. There it goes. Okay, so first step here, we're just going to group them into 2 separate binomials. And then we just want to consider each one separately. Now, something we've seen, I think it was yesterday, was that video. If you watched it at the beginning of this Pear Deck, it showed a way of writing out a polynomial so you can easily recognize if there's common factors. So I'm going to kind of do that with this polynomial that we have right now, just so we can tell if there's any common factors. And if you can easily see that anyways, that's great. If you can't, then this is something else you can try. So I have 3 x's being multiplied together. And I have a 7 being multiplied with an x and with an x. We do this to the second polynomial, or the second binomial. I have a 5 being multiplied with an x, and 35, if I write that as a product of prime factors, 35 is the same as 5 times 7. So this is an optional thing to do to help you see if there's any common factors. If I look at the first binomial, x cubed plus 7x squared, if you see a pair of common factors, you can circle them. There's a pair of common factors. And I have a second pair of common factors. Okay, so I can see that there are 2 copies of x that I can factor out. So we're going to pull out one x and another x. And then what's left over is just x plus 7. If I do this to the second binomial, I can see I have a pair of 5s that are common factors. So I can pull out a 5, and then what's left over is x plus 7. I'm going to rewrite this, so instead of saying x times x, I actually have x squared and so I've now done the first and second step that we didn't do yesterday, and now we're at a point where this looks like something that we did see yesterday. We have two terms, both with a common binomial factor, and that common binomial factor is x plus 7. So I can actually factor out this common factor of x plus 7. And then what's left over is x squared plus 5. Now, when I pull that x plus 7 out, I need to make sure I keep parentheses around it, because otherwise it would mean something different if I didn't put those parentheses there. But this is now factored, so I'm just going to rewrite it all in one color. And that right now on the meat is just if you were to take example 7 and expand each of those terms into prime factors. Okay, 3x cubed is 3 times x times x times x. 12x squared is 2 times 2 times 3 times x times x. 6x is 2 times 3 times x. And 24 is 2 times 2 times 2 times 3. And then you can see there is a common factor that they all four have in common. So you want to factor that out first.